Question 6 we reach now. We'll look upon the CSEC Mathematics, May 2021, past paper. Question 6 say, Farmer Brown makes troughs to feed his farm animals using wood that is 5 centimeter thick. This looks like I had my raise. Put a chug feeding in there. In your mouth, right? Really rough when you go feed them, you know. Man, they make up nice and fight for the feeding. They're aggressive. But anyway, as shown in the diagram below, the troughs are rectangular based, open at the top and have external dimensions of 300 centimeter by 190 centimeter by 160 centimeter. Alright? Them say show by calculation that the internal capacity or the volume of the trough is 8,091,000 centimeter cube. Let me clean up over here so me and then copy over it because I still have some work from before over here so let me kind of erase some I have. Let me see now. This here so. Alright. Look good. Alright, so let me just copy the trough and put it over here so. Alright. So this are the trough. And then it says show by calculation that the internal dimensions are 8 million odd centimeter cube. We see what I go on with it. I'll go on through this thing here now. Internal dimension. The volume. A volume then say, right? Yeah, the volume. Internal capacity. This is the volume. Alright. Now, if you draw just the internal part of the trough, let me just put a little thing together here, so. But what more you do now? I pause the video and try it. Try it for at least 15 minutes. Right, so pause it and go ahead and try it. Okay, so you're done. So, the thing is, you know, I'm supposed to get ready. But anyway, here, this is a 5 centimeter thick. All of this are 300 centimeter. So you have to take 5 off or so, and 5 off or so. So 300 minus 5 minus 5. Minus 5 from one end, you get 295 minus 5 from the other end, you get 290. So you have the width. The width at 290. Now by the right centimeter here, so too much writing. But at 290 centimeter. Alright, you see this apart now from one end to the next are 190, but from the inside part to the inside part would that be 190 minus 5 over there, so minus 5 over there, so it will be 190 minus 10, and that gives you 180. So that a part of 180. How about the height? Alright. You see, when it comes to the bottom of the trough, you know, it have a bottom panel. And if me put the hidden detail at the bottom part, I think would have come in something like this. Right? We are 5 centimeter thick. If you have 160 and drop 5 off it, you have 155. So that would have give 155. So, we see what would have gone here so now. The volume would have be 290 times 180 times 155 equal. Alright. Oh, let me write the formula. The volume would have be 290 times 180 times 155 equal. Remember in an exam you have to show the subtraction, show everything all working. Or maybe them mark for the subtraction and everything there. Even though I never show it, or if you show it in an exam. Alright. Oh, I will press for me there. So 91,000. 8091,000. So that's 8091,000 cm3. Alright, so that is what you have. After that now, let me say, calculate the volume of wood needed to make a trough. Alright, you want the volume of wood needed to make a trough. This is something here. The volume of wood. Let me just rewrite this here. Alright, now you have, suppose you make the front go right across and you hitch the middle between them. Right? Or you could have made the side full length and you hitch the front and back between them, but make the front go right, make these go right across. So the front and the back are full length. Right? So if you do that now, is a situation like this you'd have. To the front, the board I use to make the front would have kind of look like this. So, would have be 300, the thickness of 5, and the height of 160. So, this is the front. And also the back, if you choose to make it that way there. Alright, the side now, the left and right side, will look more like this now. Let me see now. You have each in between them. So you have 190 minus 5 minus 5. So that's what will be 180. You see? You cut off 5 from here so and 5 from over here so. If you each between the front and the back and nail it. So you have 180 and you have the full height 160 and the thickness of 5. So left and the right. You see, I two of them. So we just write left and right on it. And then the base now. Would that be what? I want to put the dimensions of the base. If you draw the bottom of it like so. Now, the base would be 190 minus 5 minus 5. So you have 180 long. And then across, you'd have to minus 5 and minus 5. Right? So that would have be 300 minus 10, 290. That would have be 290. You see? Let me see. And the thickness of 5. So then dry it. Takes so long time, you know. Alright. Okay, anyway. That's how you go. So, the thickness of 5. So the total volume now. Oh gosh. I don't think this one put here so. So the volume of wood. Volume of wood then, so right? Calculate the volume of wood. So V would that be 300 by 5 by 160 for the front and the back. 300 by 5 by 160. You could have said plus, this are the front, and the back would have be 300 by 5 by 160. You could have just multiply this by 2, so I could just multiply by 2 because that's what them. By 2 plus. Alright. About the left side and the right side now. 180 by 5 by 160. You have 180 by 5 by 160. That's for one side, and it applies to the two sides. So you multiply this by 2 to get the two of them. Plus. And then the bottom would that be 290 by 5 by 180. Alright, so we want to see the volume of wood. What that would have come to. And we can go through the calculator now. So you have 300 by 5 by 160 by 2 equal that. Alright, let me just plus, let me use bracket. Not necessarily have to use it, but me use it. 180 by 5 by 160 close bracket. Oh, not close the bracket yet. I two of them by 2 close bracket equal that plus 290 by 5 by 180 equal 1,029,000. 1,029,000. Now that, let me look back on it to make sure. So 1,029,000, right? Centimeter cube. So you see that, alright? The volume of wood. That would have been it. Alright. The next thing now, what them say? I have to do. That's what them say. Farmer Brown must paint the internal surface of the trough. Now, given that 1 gallon of paint covers 28,000 cm cube of surface, determine the total amount of paint in liters that is needed to paint the internal surface of the trough. Alright. The internal surface now. I have to go find that. So make it come back to this thing here. You see, you go and paint the inside of the front, inside of the back, inside of the left, inside of the right. So you're ready for paint. Let me just erase them things out we have already. What else we have? Let me just erase some of these down here, so. Alright? Oh, some markings up here, so. Now, the thing is this, the internal surface. The surface here, so, how would I paint? If you look through this, on the inside, we're really going to paint. We're really going to paint here, so. Let me see. And this surface you're going to paint. So, this will be the front, the inside surface of the front. We call this the front. Would that be 160 centimeter high times 300 minus 5 on the left minus 5 on the right. That's a 290. Alright? Plus, the same thing would have happened around at the back. We paint the back at the same thing. From this corner to this corner. Right? This is what I'm going to talk about. From here to here, so. That would have be the same 290. Oh, by the way, one thing, the base did it. So me leave out something. Now if you go make a correction, you see the base, the bottom right, the inside. So I'm going to have to drop 5 from under, from off of the 160. Right? So 160 minus 5, that's a 155. So this number should have be really 155. Because you know, come right down to the bottom of the board, at the inside of page. So from the top, go right at the top of the bottom, and the bottom of 5 from here. So it's really from here to here available for page. So 155 by 290. Then the back, right over here. So now, remember this is the front, this is the back. At the same 155 by 290. You see? Then the right. The right part would that be what? The inside would that be the same 155 high times. Now, the thing now extend all the way along the board, you know. Come here, so, and here, so. So 190 minus 5 minus 5. So it will be 180. Because I know the entire length, so you know, you have available for paint. You have to paint from here to here, inside. It's from here to here. And you drop 5 centimeter. Because the board will go across the front and the back, a 5 thick. So you have 5 centimeter, you lose 5 centimeter at the front and 5 centimeter at the back. So you have 180 by, and the height now, all the way from the top, go down to where the base there, 155. Remember, on an open bottom, you know, it have a base, 5 centimeter thick too. The same argument applied to the left. The left hand part will be 155 by 180. You see? Then the base. The base will be 1 off. Now, let me just erase some of what I have here, so, and deal with the base. You see, if you look, if you're able to look through the trough, right? Let me draw that, so. This come right down, so. And this comes so. This comes so. the base we are look at, right? And this will cross so. This kind of lean, but you get the idea. This is a piece of board that comes so. This comes so. I have to do a little erasing right here so. Right? Alright. So the base now. 300 minus 5 minus 5, that's a 290. The base would have been 290 wide. So the width of the base at 290 times then the length height. You take 5 from the front and 5 from the back. So at 190 minus 5 minus 5. At 190 minus 10, it comes down to 180 by 180. That's the surface. So the total surface of that. Alright? So, here now. The surface of each. That'll be what? One, the surface. Oh, this thing I jump up and down so. So the calculator now, what you're going to have is 155 by 290 equal 44,950, 44,950 plus 155 by 290 at 44,952. And you have 155 by 180 now. 155 by 180 give you 27,900. That's a 27,900 and 27,900. And then you have the 290 by 180. So 290 times 180, that'll give you 55,200. 55,200. So what is the total? Alright, we're going to see the total surface here in terms of the centimeter cube. You have 44,950. You have two of them, so you multiply by 2 plus, and you have 27,900. You have two of them, so times that by 2 plus, and you have 55,200. 55,200 equal 200,900. 200,900. Alright, 200,900 centimeters square. Alright, so now, what happened? Them say 1 gallon of paint cover 280,000 centimeter cube of surface. Determine the total amount of paint in liters. So 1 gallon at 280,000. So 1 gallon equal 280,000 centimeter cube. Alright? And 1 gallon of paint to cover that. You want the amount in liters. Alright, so now, how much gallon of paint you actually use? So, amount used would have been 200,900 over 280,000. So, use a full gallon. So, you have this divided by 280,000 equal 0.7175 gallon. 0.7175 gallon of paint. But they said they want it in a liters, so just rub out this thing from before. Them say 1 gallon is 3.79 liters. So here, 1 gallon equal 3.79 liters. Alright. So 0.7175 gallon equal how much liter? Call it X, liter. Right? Now, if 1 gallon, 3.79 liter. When you say gallon, you say 1. When you say liter, you say 3.79. That means if you go from gallon to liter, you must multiply by 3.79. So X liter would have be multiply this 0.7175 by 3.79. What do you get for this now? This times 3.79 equal 2.72 liters. So you need the total amount of paint in liters that is needed to paint the internal surface. Alright. So 2.72. Look like question 6 done this up. So 2.72 liters of paint.